Okay, welcome back, everyone. Thanks for joining us again. We've talked a lot now about the energy balance of the Earth and how ocean circulation works. And so now we're going to start thinking about the climate and how that interacts with the ocean and how we can expect the climate to change in the future. So the first thing I want to do very briefly is just talk about some fundamental terminology. And I think this is something that is really challenging because it shows up a lot in popular discourse about this topic in ways that can be really confusing and hard to think about. So the main idea is that we want to distinguish between weather and climate, because frequently people talk about weather as if what they were actually seeing is the climate. And so one way to think about this, a nice analogy, is that weather is basically what you would wear to go outside today. And the climate is more like what you would need in your closet to capture the range of conditions you might expect over the course of a year. So weather is really just thinking about a short-term average or short-term change in what's actually happening in the atmosphere. And climate is an average over the course of decades. So the climate is not going to be able to necessarily tell you exactly what's going to happen today, but it can tell you what on average you should expect today. So one way we can look at that is by looking at temperature data gathered from a particular place. And so this is a graph of air temperature, daytime air temperatures at the Washington National Airport in Washington, D.C. And it's just 1 year of data, so it's basically giving us every daytime temperature over the course of the year. And what you can see is that from day to day, you can get pretty big changes in the temperature. And so if I know what temperature it was on January 4th, I might not be able to make a very good prediction about exactly what's going to happen on January 5th. And you can kind of see this big sort of seasonal change. But again, day to day, you can have some very big oscillations. So this is just what was the weather that year. If we want to start thinking about the climate, we need to look at longer term averages, and so gather data over more time. And so we can start by just looking at 3 years of data, and on this plot, the purple dots are the individual data points from each of those 3 years, and then that dark purple line is the average over those 3 years for each day. And what we can see is two things. One is that the day-to-day spikiness has gone down a little bit. That average has sort of smoothed things out. But if we look at the range of values that have happened on any given day, it's pretty large. So if we then carry this over into 30 years, now we can see that that average line over the course of 30 years is even smoother, and we can really pick out a very clear seasonal oscillation. But for any given day, there is a huge range of temperatures that have actually happened over the course of the day. And so this is why it can be problematic when someone says something about how, oh, it's a really cold day in the summer, so climate change can't possibly be real, because that temperature on that day is just part of that overall average. And so if you really want to be thinking about climate change, you need to look at how this purple average line is shifting over the course of a longer time period. 1 day is not enough. And so this is really what we mean when we talk about climate. We're looking at the long-term average at a particular location. So we're going to look at a video that helps us illustrate this. And to do this, I'm actually going to leave PowerPoint for a second because my computer does not like it. And so we're just going to look at this video. And so what you're seeing in the colors here on top of the map is precipitation. And so what I would like you to do is just pick a particular location where you're familiar with what you think the weather and the climate are like, and then think about what you're seeing in terms of that precipitation. And I'm going to let it play for a while. It's a 2-year video. And then after we've been looking at it for a while, I'm just going to highlight a couple things. So again, this is atmospheric circulation. If you look here in the Atlantic, you can see some hurricanes, and same thing over here, some cyclones. They're the same kind of weather or event. We just call them different things in different basins. So here we have a hurricane about to hit the coast of the United States. So let's go up here to the Pacific Northwest. We're starting to see some of these tendrils of atmospheric precipitation hit the coast here. There's another one. So each one of those is an individual weather event. So that might be one of our big winter storms that comes and hits the coast. And what we can do in thinking about how this video helps us think about the difference between weather and climate is look at what's happening at a particular location over the course of this 2 years. So a really stark example is the Sahara here. So if you watch this entire video, I don't think you will see a single precipitation storm event transition through this area. So that means that on any given day, it's probably not raining, but it also means that over the course of 2 years, you would also not expect any rain really whatsoever. Whereas over here, you know, right now we're saying, oh, there was a rain event. Here's another rain event. And there's some separation between those two. Here's a couple more. And now right now they're coming really close together. But there's some time between those. So on any given day, it might not be raining. But if you stack up all of those storms back to back to back over the course of the winter or the course of several years, now you start to get a picture of what the climate is like in Seattle on average in the winter. So again, any one of these bright spots here is giving us an idea of a weather event. And then if we look at those over the course of the whole 2 years, we start to get an idea of what the climate is like. And over here, you would notice that there's a time of year when there's a lot of those precipitation events back to back to back. And then there's a time of the year when they are either non-existent or much more spread out. And that correlates really well, obviously, with our sort of wet season, dry season approach that we have in the Pacific Northwest. I'm going to stop this. Okay, so if we go back over here, so one of the things that we can think about in terms of thinking about how does the ocean affect the climate that you might expect is we can think about 3 different cities in the United States that are all at the same latitude. So if we think about some of the stuff that we've talked about previously with sea surface temperature, we know that as you change in latitude, you're changing that balance between the incoming and outgoing radiation. But there's a lot of nuance there, and it turns out that that's not quite enough to help us understand what the climate might look like in a particular location. And so we see that San Francisco is this blue line, which is a very actually relatively narrow seasonal cycle. It doesn't get that hot in the summer, it doesn't get that cold in the winter. Whereas if we look at Richmond and Wichita, we start to see this really, it gets a lot colder there and it gets a lot warmer there. And Wichita is actually the one that has the most extreme range. And so this is maybe something that you've thought about before. A lot of times when we think about West Coast cities, we think about them having a very temperate climate. And one of the things that contributes to that is that the weather is typically moving from west to east. And we're right next to this huge ocean, which has an enormous heat capacity. And it has a huge heat capacity, especially relative to the land. And so it takes a lot more energy to heat this up and a lot more energy to cool it down. And then that is directly impacting what we're seeing here right off the coast. Whereas if you're in Wichita, the weather you're getting has been spending a lot of time over the continental United States. So it's been heavily influenced by the surface temperature of this landmass. Richmond is not quite as extreme as Wichita, and if you notice, it's really very close to the Atlantic. Again, the weather's moving from west to east, so this isn't going to play as big a role, but it's still adjacent to that really large body of water that has a pretty enormous heat capacity. So this is another thing that is important to think about in the climate, is it's not just your latitude. Where you are in proximity to the ocean is really important. And we can see this a little better when we start to think about ocean circulation on a big scale. And so again, this is one of those maps of sea surface temperature. And we can see that sort of generally there's that hot at the equator, cold at the poles, but then there's some nuance in there. And so in addition to that whole ocean versus land heat capacity idea, There's also what is the actual ocean circulation doing, and how is that influencing not just the fact that there's water close to the continent or not, but how is that influencing what type of water is close to the continent. So I just want to show you two examples. We're not going to get into this in a huge amount of detail, but the ocean, as I said, stores a huge amount of heat, and but is also much more difficult to change than the land. So if we look at the Atlantic Ocean for a little bit, this is probably a feature that's shown up to you in previous slides, since we've been spending a lot of time looking at sea surface temperature. But this track right here is the Gulf Stream. And it's a huge current. It's in full depth current carrying a lot of really warm water from the tropics to the higher latitudes. And even though the Atlantic Ocean is very large, it is still a fairly narrow basin compared to the Pacific, for example. And so what you'll notice is this Gulf Stream is so powerful that it actually brings really warm water to pretty high latitudes. And so if you are thinking about living in England, England is at a higher latitude than Seattle or any part of Washington state, but it has equally mild temperatures year round. And it doesn't get the kind of extreme weather that you might expect from being at 50 degrees north. And the reason, one of the contributing reasons for that, is because you have this really strong Gulf Stream current that brings warm water anomalously far north. So instead of having a really cold body of water influencing the atmospheric currents coming in, you have water that is much warmer than you might expect at that latitude. If we go over to the Pacific Basin, by contrast, the Pacific is enormous. It is several times larger than the Atlantic. So we still see this very strong western boundary current, as we call them. Over here, it's called the Gulf Stream. Here, it's called the Kuroshio, and there's the Kuroshio extension. And the current does get quite a ways into the Pacific. And if you notice, if you contrast here with here, this water appears to be warmer than this water. But the basin is so much larger that we don't see that influence over here. And so England is roughly here on this latitude. And you can see that these temperatures are significantly cooler than the ones that we were seeing in England. So that's one way in which the circulation can influence the climate, is these powerful currents bringing warm water to anomalously high latitudes. You can also see right now there's this cool tongue of water protruding south, and you actually see that all the way in here. And so there's a couple of different things that can contribute to that. One is if we think about that gyre circulation going around like this, maybe that's bringing some of those cooler waters up here farther south. But the other thing we have along the Washington, Oregon, California coast, and something that's really important for our fisheries here, for example, is we have seasonal upwelling. And so in that case, what you're getting is you're getting water from deeper in the ocean that's upwelling near the surface. The water at the depth is cooler than the water at the surface. And so what you do is you bring cooler water up to the surface. And so not only are we next to this huge buffer, the ocean, but in the summer in particular, we are next to a cooler body of water than we might otherwise expect. And so that's another thing that plays into keeping our climate reasonably temperate. So we can take this reasoning and we can extend it all over the world. Anywhere we see coastal upwelling, we could expect that to moderate the local climate. Anyway, we are seeing a current bringing really warm water to a particular location, we could also expect that to influence the climate. And so if we see changes in those currents or changes in the sea surface temperature that's being moved around by those currents, that's a place where we might start expecting to see some of the impacts of climate change play out. And so Sarah's going to get into this in a separate video where she's going to start talking about heat transport and climate change and what we can expect in the future. So thanks for joining me for this section.